In this video, I'm going to demonstrate how to use a geometric mean to solve sides and find sides of similar triangles formed by an altitude drawn in a larger right triangle. And we're also going to discuss what the geometric mean is. So the geometric mean is a special average that is found by doing the product of two numbers, okay, multiplying two numbers and taking the square root of the product. We've been working on proportions and similar figures, so we're going to start off with proportions first. So here we have to solve for a value of x in these proportions. So in the first one, remember proportions, we use cross multiplication. So to multiply, I'm going to get x squared equals 256. Take the square root of both sides. Square root of both sides. 256 is a perfect square. So our answer is going to be 16. When we're dealing with the geometric mean, we're dealing with the principal square root, the positive square root. Okay. Same thing here. I'm going to multiply using cross multiplication. Y and y is y squared. 25 times 2 is 50. Just take the square root of both sides. 50 isn't a perfect square, so either you can simplify the square root using the prime factorization method or the perfect square method. If we do prime factorization, I know 25 times 2 is 50, and 25 is 5 times 5. We have all prime numbers here now. So I have a set of 5s and 1, 2 that's left over. So remember, the number that doesn't have a pair, it stays inside of the radical. And one number from the pair comes out of the pair, so you have 5 square root 2 for the value of y. Lastly, z times z is z squared. 10 times 2 is 20. Square root both sides. 20 isn't a perfect square, so using prime factorization, 4 times 5 is 20. 4 is 2 times 2. Have a pair of 2's, 1 5 left over. So z is equal to 2 square root 5. Okay. So we're going to take the same idea. If you notice here, the variable is at the top and bottom of each side of the proportion is the same. So this is what happens when you do the geometric mean. So I want to find the geometric mean of 8 and 11, right? So the first thing I'm going to do is write down the formula for geometric mean. The formula for geometric mean is a over x equals x over b, where a and b are the numbers that you had. So 8 could be a, 11 can be b, or vice versa. And you're just going to substitute them in and solve. So I'm going to have 8 over x equals x over 11. Cross multiply. So that's going to be x squared equals 88. 88 isn't a perfect square. All right. So if you simplify that square root, you're going to end up with x equals 2 square root 22. Okay. Same thing can be applied over here with 18 and 50. Okay. So 18, draw that one back a little bit. 18 can be A, 50 can be B. So I'm going to have 18 over x equals x over 50. Cross multiplication, so x squared equals 900. Take the square root of both sides. X is going to equal 30. So the geometric mean of these numbers, sometimes you may end up with a radical answer and sometimes you may not. But the idea is you're creating a proportion using cross multiplication and simplifying the radical. There will be some times where you give decimals, but overall we're going to stick with the radical form. So the question is, how does that help us when we get to the type of problems where we have these huge triangles that have multiple triangles in it? So let's go there next. Alright, so in this picture I have this triangle in white, and it has an altitude drawn down the center. A represents the altitude here in this picture. just so we can know what's labeled. So if you look here, I have different parts labeled. H represents the hypotenuse of the large triangle here. And then I have two P's. This P and this P both make up parts of the hypotenuse. And then I have the leg here and the leg here. These are the legs of that right triangle, and of course the altitude in the middle. The altitude is this line drawn down to the hypotenuse, and it forms two right angles with the hypotenuse. All right, so when you're using the geometric mean to find it, it might make it a little simpler than having to take this big triangle and split up the two smaller triangles and put the appropriate corresponding angles in appropriate place. That can get confusing. So we're going to try this way instead. There are two ways to use this. So the first one is called PAAP. So you have a part altitude relationship going on here. This is useful when you know about the parts or the altitude of this type of right triangle altitude situation with similar figures. So this is what you would do. You would take one of the parts of the hypotenuse, divide it, or set up the ratio of that with the altitude of the triangle is equal to the altitude divided by the other part. That's one way you can do it. Or you can use the hypotenuse leg part method formula. So basically you would take the hypotenuse and set up a ratio with it and a pair of sides and legs. A pair of sides and legs. So you have a pair of parts and legs. So the orange goes with the orange, the blue goes with the blue. So if I put an orange leg, I have to have an orange leg and an orange part. Or if I were to set it up with the blue leg and blue part, that's what matches. So they have to match when you use this one, all right? So we're going to actually start working with these and showing what it actually means. So for example, in these triangles here, I'm first going to identify what I know. So the first thing I know is I know the hypotenuse of this triangle. The hypotenuse of this triangle is going to be 9. Okay, so this big triangle. I'm looking at this triangle as well, and I have this part here, which is 4. And I have another part that I know that's 5. I don't have any values on either leg of the triangle, so I don't know that. I don't know that. And I know I'm trying to determine the value of the altitude, which is x. X is the altitude of the triangle. So we have a choice. So we're going to use PAAP or HLLP. Which one? Well, let's look. I don't have a leg value on either of this, and I don't have a leg as an unknown. So this one isn't going to be helpful at all. This one isn't going to be helpful. But this one is. So let's set it up. Remember, it is the part over the altitude equals the altitude over the part. So the part over the altitude equals the altitude over the part. So I know the part that is in red is 4. The altitude is x. The altitude is x, and the other part in green is 5. Cross multiply, x squared equals 20. Take the square root of both sides, so x equals 2 square root 5. So I know the value of the altitude would be 2 square root 5. Let's apply that same idea here. So I have this hypotenuse. I know the whole side is 16. I have parts. So I have one part that's 12 and another part that is 4. I don't have any leg values here, so that's not helpful. And I know my altitude here is represented by Z. All right. So once again, it's going to be PAAP, part, altitude, altitude, part, or HLLP? Well, I had the hypotenuse, but I don't have legs, so it can't be this one. It has to be this one. So I'm going to set it up. The red part divided by the altitude, that ratio, equals the altitude over the part. So the red P is 12, the altitude is Z. The altitude, once again, the altitude is Z, and the part is 4. So I have Z squared equals, equals 48. Square root both sides, square root both sides. So Z is going to be equal to 4 square root 3. Okay, let's do a few more. Looking at this one, so I know the hypotenuse already on this one is 10. And I have these other things here, all right? So I have this red 8. So I know that's a part. All right. And I have this purple X, that's a leg. So right now I have a part, a hypotenuse, and a leg. Oh yeah, I can find this part right here. I can find the other part. Well, if the hypotenuse is 10 and this is 8, that means this part would have to be 2. I'll use purple so they can correspond with the same color, so that's helpful. So this part is 2, because 2 plus 8 is 10. All right, so once again, are we going to use part, altitude, altitude, part, or hypotenuse, leg, leg, part? And remember, the legs and parts have to match. You have to have matching sets. So you have the hypotenuse, you have a leg and a part, but you don't have the altitude, so it can't be this one. So we're going to set up HLLP. So H over the L and the L and the P. And if you see, it was the purple L and P that matched together. Don't involve the red one in there because it's not going to be helpful. So the hypotenuse is 10. The leg is X. The leg is X. And the part you have is 2. Cross multiply x squared equals 20. Take the square root of both sides. X equals 2 square root 5. All right. On this one, the hypotenuse is 25. You have 19. That's a part of the hypotenuse. So I'm going to make a purple P. The 6 is the other part, so that'll be a red P. All right, and we want to find out the value of y. Y is a leg of that triangle. So, are we going to use PAAP or HLLP? Once again, we don't know the altitude, so that's not going to be helpful. But I do have the hypotenuse and a pair of parts and legs, so I'm going to use HLLP. So it's hypotenuse over the leg equals the leg over the part of the hypotenuse. And if you see, I had the red leg and part, so that's what I'm using here. So the hypotenuse is 25 over the leg, which is what I'm looking for, that's y, equals y over 6. Okay. Going to cross multiply, so y squared equals 150. Square root both sides, square root both sides, so y's value is 5 square root 6. Okay, so just a recap, remember, when you're studying these problems, you're going to use geometric mean and you're going to simplify. Please, please, please make sure you remember that the setup is important. label the triangle. So if you have this big right triangle, make sure you label it correctly. All right.